We're going to look at section 1.1, and this section is all about problem solving. And so this is one of the more challenging sections in this whole course, but it's a great section to get you introduced to the math course, and I think that you'll find it very helpful as you start in this course. I hope that you have printed out some of the outlines of the notes that I have in Canvas for you. That'll make taking notes a whole lot easier for you. There will be times where I will suggest that you just watch the slides and then take notes as you replay the videos, and then other times that I just tell you to take notes along with the video. So the problem solving strategy. So there are 6 steps to a problem solving strategy that I like to use. And these are with some of your more complicated word problems and math problems that you're going to encounter in this course. So the first step is going to be to read the problem. And that may seem like a given, but you'd be surprised how many times that we just kind of take it for granted. And depending on what type of reader you are, you may have to read it multiple times. And that's actually the second step, is reread the problem. So I am actually not a really good reader, and so I tend to have to read the problem multiple times. And that's okay. You read the problem until you kind of get an understanding of what the problem is asking. And so you just read the problem as many times as it takes until you get a grasp of what you're dealing with. And then the third step is that you prepare for the answer. Now, what that means is that you have to kind of know, what are you looking for? And so usually what I do is that I go to the bottom of the page, and if the question is asking for the number of miles, then I will write a blank and I will write miles. Or if it's asking for the number of shoes, I will write a blank and I will write shoes. If it's asking for the number of minutes, I will write a blank and I'll write minutes. And that's to kind of hold myself accountable, because I want to make sure that I answer the question as it's being asked, because so many times we work through a problem and we get an answer, but it's not the actual answer that the question is asking. And so you want to make sure that you actually provide the answer that the question is asking you. So prepare for the answer. Number 4 is go back through the problem, underline, highlight, or write facts. So I like to underline a lot, and you'll see me doing that through a lot of these problems, is that anything that's important, I go back through and I underline. Then I do this a lot. I plan, I draw pictures, and then you actually go through and you solve and you look for patterns. Now, I am not an artist whatsoever, but I will draw figures. I will, grab clip art or whatever I need to do. I will make sense of the problem. And so that's what you want to do, is that you are just trying to, it can be chicken scratch. It doesn't matter. You just want to make sense of the problem. And a picture, if you can draw a picture, that will help you to make sense of the problem. And so that will help you a lot. And then finally is that you want to check your answer. Did you actually answer the problem, and does your answer make sense? And so you want to make sure that your answer actually makes proper sense. And so check your answer and make sure that you answered it correctly. So here's where I like to emphasize, does your answer make sense? Let's say you had a question and the answer was supposed to be, let's say the question was that you were supposed to figure out how many shoes does Fred sell at the shoe department in one day? Okay, so let's say that Fred is your star shoe salesman. So, and you work out the problem and you find at the end of the day that Fred sells 450,698 pair of shoes. Okay, even if Fred is your star shoe salesman, I am just going to go out on a limb here and say that Fred had a really spectacular day if he sold 450,698 pair of shoes in one day. You see what I'm saying? I'm thinking maybe, just maybe you might have made a little mathematical error there. And so I would go back and I would say, maybe I might have made a little mistake somewhere. And I might go back and I might check my math. And just because that just doesn't seem quite right. Okay, so it's really helpful to ask yourself, does it make sense? All right. Okay, now we're going to go through several problems that you have in your homework, and I'm going to try to help you. You may have similar problems to these. They may be different numbers or things like that, but I want to kind of walk you through a mindset of how you might work through these problems. Now, this particular problem is number 10. It says, this is not a typical math problem, but is a problem that requires only common sense and sometimes creative thinking. Okay, I don't agree with that because these are hard problems. I'm just going to go ahead and say that. So anyway, don't get your feelings hurt if you think that these are really hard problems that do require some deep mathematical thinking, because I think that they do. So there you have it. At 4 o'clock, the grandfather clock struck 4 times. If it was 30 seconds between the first and last strokes, how long will it take the same clock to strike 10 o'clock? Okay, so we read the problem, and now we're going to kind of reread the problem. And as we go along, we're also going to prepare for our answer. What is this question asking? Okay, so it says at 4 o'clock, the grandfather clock struck 4 times. If it was 30 seconds between the first and last strokes, how long will it take the same clock to strike 10 o'clock? How long will it take the same clock to strike 10 o'clock? Okay, so it's asking me how long will it take. So it's asking me a measurement of time. Okay. So I'm going to prepare for my answer, and I know that that is a measurement of time. And I know that that time is going to be, I'm going to look in my problem for clues as to, like, if it's a measurement of time, because this says how long, then I want to know if it's in time, do they want minutes, seconds, hours, what do they want? Well, they gave everything in seconds, so they're going to want things in seconds in my answer. Okay, so I'm going to go ahead, I'm going to underline some things. At 4 o'clock, the grandfather clock struck 4 times. It was 30 seconds between the first and the last strokes. That's important. How long will it take the same clock to strike 10 o'clock? Okay, so I went ahead and prepared for my answer the number of seconds. Okay, so this is all, I think that I have kind of a good idea of what they're talking about. So now I'm going to kind of do kind of a little diagramming here to help me understand kind of what's going on. Because here's what typically happens is that a lot of my students will they'll automatically just start, they'll grab a calculator and they'll just start dividing numbers out, and they end up getting this wrong. So this is where a diagram kind of helps you. And so let's think about this. So what happens is that I want you to think about the grandfather clock striking, so that like dinging. Okay, you have to understand I'm a pretty simple Alabama person, and we think about striking or dinging. So here's my first strike. So I have a strike and then a pause, and then a strike, ding, pause, strike, pause, strike. Okay, so there's my 4 strikes. So now that's, ding, pause, ding, pause, ding, pause, ding. Okay, so that's what happens at 4 o'clock. Now, so then it says it was 30 seconds between the first and the last strokes. So kind of mapped this out for you. Between the first and the last strokes. So notice how I kind of put that in here. So between the first and the last dings, I have 30 seconds. Okay. So let's kind of think about what that means. So at 4 o'clock, we had 4 dings, right? So we had 1, 2, 3, 4 dings. We had 3 pauses. So we have this 1, 2, 3 pauses. And we had 30 seconds in here in these pauses, right? So 3 pauses and 30 seconds in those pauses. So really, if you think about it, each of those pauses were 10 seconds. So let's just wrap our minds around that. Does that make sense? That makes sense to me. 4 dings, 3 pauses. Makes sense. All right. So then it says the same clock, and we want to do 10 o'clock. So now let's think about what's going to happen at 10 o'clock. So at 10 o'clock, we're going to have 10 dings. Now, I won't ding for you 10 times. You're welcome. But if you think about it, you're going to have 10 dings. How many pauses are you going to have? So if you had 4 dings and 3 pauses, thank you, my class, you're going to have 10 dings and 9 pauses. Now, if it's the same clock, the pauses should be the same amount of time, I would venture to guess. So your pauses should be 10 seconds long, wouldn't you think? So you're going to have ding, 10 seconds, ding, 10 seconds, right? So you're going to have 10 dings, 9 pauses. How many seconds? Well, that means you're actually going to have 90 seconds. So at 10 o'clock, it's going to take 90 seconds to reach 10 o'clock. Pretty cool, don't you think? I think it's pretty cool. So, yeah, there you have it. So, but it really does kind of take mapping it out and putting this little diagram out like this, and it helps you to kind of see it a little bit differently. Okay, there you have it. Now we're going to look at number 13, one of my favorite ones. A boy cyclist and a girl cyclist are 10 miles apart and pedaling toward each other. The boy's rate is 2 miles per hour and the girl's rate is 8 miles per hour. There's also a friendly fly zooming continuously back and forth from one bike to the other. If the fly's rate is 7 miles per hour, by the time the cyclists reach each other, how far does the fly fly? I don't know why, but this problem brings back terrible memories of like standardized tests in high school. Yes. Like, I don't know. It's just those terrible tests. I'm sorry if I'm making you have terrible flashbacks, but anyway, it just does. They always had these questions like this, except I don't remember anything about a fly. So, but I mean, you know, they always had those, how long till they meet each other questions. And so anyway, I hated them. I still don't like them. So, yeah. Okay. So let's underline some things. The boy cyclist and girl cyclist, they're 10 miles apart. The boys' rate, oh yeah, they're pedaling towards each other. That's important. They're going towards each other. So that is really important. They are, oh, the boy is 2 miles per hour and the girl is 8 miles per hour. I think that that's really funny, how the boy is going so slow and the girl is going so fast. I wonder why. Anyway, then you have this friendly fly, which is going back and forth between the two. And why the fly is going back and forth between these two people that are 10 miles apart really makes absolutely no sense. But anyway, only in the realm of a math problem would this make sense. The fly's rate is 7 miles per hour. How far does the fly fly? How far does the fly fly? So preparing for the answer, how far does the fly fly? I just really like saying that. How far does fly fly? How far is length? Miles is my guess because everything was given in miles. So we will prepare for our answer in miles. Now, we could go at this with using a formula, and distance equals rate times time. I mean, you know, we could do all of that. I just wanted to do this really, really easy. Can we do this easy? Please say that you want to do this easy. Say, Lisa, we want to do this easy, Miss Baker. Miss Baker, Lisa, I don't care what you call me. We want to do this easy. Okay, great. Let's do this easy. We are going to do this super easy. Okay, the easiest way that I can tell you to do this is that let's just take it an hour at a time. Okay, and like make a chart. Let's just see where they are after 1 hour, then after 2 hours, and see where they are. I mean, okay, so let's just see where they are. So, first thing we're going to do is let's see where they are in 1 hour. All right, so I'm going to check on the boy. Let's check where the boy is. It says that the boy's rate is 2 miles per hour. That's why I said let's check on him after 1 hour, because he's going to go 2 miles. So in 2 miles, he's going, in 1 hour, he's going to go 2 miles. So I know that's where he's going because he's going 2 miles per hour. So there we go. Now the girl is going 8 miles per hour. So she's going to go 8 miles in an hour. All right. Now, how far apart were they? They were 10 miles apart. Well, if he goes 2 miles and she goes 8 miles and they were only 10 miles apart to begin with, what do you know? It is our lucky day. Class, can you believe it? We got very lucky. After 1 hour, those two people meet. Hallelujah. Praise the Lord. God has been good to us today. We don't have to do any more work because the happy couple is going to meet after 1 hour. Hey, this is good. This turned out to be an easy problem. So in 1 hour, they are going to meet. There's no more work to do. Well, we have to figure out about the fly now. Okay, so now the fly has been flying for how long? The fly had to fly for 1 hour. Okay, so if he flew for 1 hour, how many miles did he fly? It says the fly's rate is 7 miles per hour. So how far did the fly fly? Well, he flew 7 miles. I just love this problem. It turned out to be easier, and I didn't have to do a single mathematical calculation. Thank you. I just loved it. And it was all because I just drew the little pictures. Well, actually, I didn't draw the little pictures. I just did the little clip art. But anyway, it turned out to be easier because I just thought about it. See, I mean, like that's the good thing about mathematical logic is that sometimes you can just think about it and it all falls into place. Okay, so there you have it. We could have done it for 2 hours and figured it up too. And I mean, you know, 3 hours or whatever. And it really wouldn't have been that bad. So, yeah, there you go. All right. Okay, now this problem does not even look like a math problem. It don't even have a single number in the problem. This is a complete logic problem. So anyway, this is we're going to translate from some kind of unknown language. We can be in language school class. Here we go. In a different language, Xander Crew means pink flamingo. All right, now I'm going to just go as I go along. Okay, this is going to get messy, but it's just going to fill up this whole slide. All right, Xander Crew means pink flamingo, and I just picked out some clip art for y'all, and I hope it works. Okay. All right, so here's a pink blob and a flamingo. And I said, I'm not sure which one is which, but I just said one of those things means Xander, and one of those things means Crew, but I'm not sure which one is which yet, so I just put it up there for you, okay? So then the meaning of Bach Paiming Crew is tiny pink duck, okay? So here we go. Tiny pink duck is Bach Paiming Crew. Now I'm going to kind of put all of these things together as I go. So I'm going to look for similarities. Do you see anything similar between these two lines? I see Crew right here, right? And I see these pink blobs. So that means that I can match those up. Pink blobs and Crew. That means that pink equals Crew. Okay, so that has to be a match. All right, so now I know that pink equals Crew. Good. Now I'm going to keep going. Paiming chic means tiny car. All right, so let me get out some more tiny car. Okay, now I'm going to look for more similarities, and I see the word tiny. I got tiny here. Okay, so tiny, then I see this word paiming. Okay, so I've got paiming has to mean tiny. All right, so tiny and paiming have to be the same. All right, so if that's the case, tiny, and paiming, then in this last thing, notice I only had two words, right? Paiming and chic. So that means that by process of elimination, then this car has to be chic, right? So car has to be chic. So then what is pink car? So pink car, which is the question, that's what the question is asking for. What are the words for pink car? Pink car then is crew chic. Crew chic. Okay, so I got that crew from up here, crew, and then chic from here. Okay. So all of that was just a logical flow from the top to the bottom. So you may have to watch this again and see how we went through that. So a question like this is going to end up being a multiple choice question, I think. So, but it'll help you to kind of go through it and logically follow those steps. All right. Finally, a question that actually looks like a math question. How many divisors does the number 8 have? Okay, so divisors, let me remind you about divisors. So when we look at divisors of a number, we're going to take and we're going to list out all of the numbers from 8 less and the numbers less than 8, so 8 to 1, okay? The divisors are going to be numbers that divide evenly into 8 with no remainder, okay? So divisors are numbers that will divide evenly into 8 but have no remainder. So in other words, 8 will divide evenly, so 8 divided by 8 is 1, and so it has no remainder. But now 8 divided by 7 does not divide evenly, so 7 is not a divisor of 8. So I can't circle 7. 6 will not divide evenly. 5 will not divide evenly. But now 4 will divide evenly. 8 divided by 4 is 2. Okay, so 3 does not divide evenly. 2 does divide evenly, and so does 1. So how many divisors does the number 8 have? The number 8 has 4 divisors. So that's a pretty easy question, but one that you just kind of have to think about for a minute. And the last question that we're going to look at is this number 15, which is similar to the last one. List all numbers less than 12 that have exactly 2 divisors. And then it says to enter your answer in a comma separated list. Okay, so we're going to all numbers less than 12. Okay, so less than 12 is strictly less than 12. That does not include the number 12. So I did 11, 10, 9, all the way to 1. So I want you to think about that. And if you think about 11 has exactly 2 divisors. So to have 2 divisors would mean that you would only have the number itself and 1. So that also means that it is a prime number. So we're just looking for the prime numbers in this list. So 11 is 1. 10 would not be 1 because it has like 5 and 2. Those are divisors. 9 is not 1 because it has 3. 8 is not 1. Now 7 would be 1. 7 only has 7 and 1. And then you would go through and 5 would be another one. Can you think of another one? So there's a couple more. So if you got that 3 is 1, and then the final one is 2. Okay, Now, here is the hardest part of this question, is putting it in the answer box correctly. I know that may sound silly, but that is the hardest part of this question. So when you go to put it in WebAssign, you've got to put it in, you have to put it into WebAssign in ascending order, 2, 3, 5, 7, 11. No extra spaces, no nothing else. You got to put it in just like that. If you put in extra spaces, if you put in a period, if you put in anything else, it's a computer that's grading this, and so it will mark it wrong. I promise. Okay. So just know that it's very specific, it's very picky, and it wants your answer just like that. So just make sure that if you're going to do all the work, that you actually put your answer in correctly. So that's why I included this particular question in my lecture notes. All right, that is section 1.1. If you have any questions or problems, reach out to me, send me a text, send me an email. I will be more than happy to help you through this. So remember that you have multiple tries on all of the questions. You have like 5 attempts at each question. So make sure that you use those attempts wisely. Take care and give it your best shot. Don't let it be intimidating to you. You will do well in this course. Thanks a lot.